Okay, yeah, I've got some vocals, so I think we're ready to go. And I want to go back to, we've got the bookshelf here, and I want to also go over to the website and go back over here for just a minute, and we'll talk about what's going on this week. Of course, next week is finals, and glad to have you join us. Kristen, glad to have you aboard. Now, there will be probably others who'll come in as usual, and you can always double back. You can see we got a lot of stuff going on this week, and that's primarily because next week, of course, is next week is spring break. So I want to talk about how we've got things lined up here, things that are due, and what's going on. First of all, you got 3 exams that are due on the 16th. And if you're smart, you'll get them done before they're due on which would be Friday. Then we have some cases that are due. Martin Beck, Ice Cold, and RMC, and they're all over from Chapter 6 and Chapter 7, and deal with transportation, some related problems. And then I have here for you the explanation. So what I intend to do is just to briefly talk about the Foster, which was due last week, and then Gorman. And then notice I've got these files that are due, RMC. And as you notice, you'll see the little green check there, so it's been published. So we'll talk about RMC without setup costs. With setup costs, then we'll look at Martin Beck, which is another case. And then I have some resources for everybody, capital budgeting basics, and what we mean by order and setup costs, what we're talking about. The Northwest Corner method, which is kind of an old style, tried and true approach, but we'll use Solver. You can use Solver to do it. And then I have some information about jobs in logistics. And since we're talking about transportation and transshipment problems and network problems, I want to let you know there are a lot of opportunities out there. These are some data from the BLS, that's the Bureau of Labor Statistics. Other careers in logistics and supply chain that are out there for everybody, and then jobsandlogistics.com. And they're always looking for entry-level people that have had quite a bit of technological background, which all of you had. And I can tell you, as I've said it over and over and over, if you sell stuff online, it's got to be shipped and taken somewhere for the sale to be fulfilled. And we also operate in a global economy, so because we do, there's always going to be opportunities for people who want to be part of the process of getting stuff moved from one place to the other. So I would encourage you to do that and make use of those resources over there as well. Now, as I'd mentioned, what we wanted to do was to review Foster and then Gorman, okay? And so I'm going to go back over here, and I have the Foster key, and I've got the Foster key opened up, published for everybody, as well as Gorman. So we want to take a look at it very quickly, okay? And I'll just go ahead and download this. And this is a transportation problem, okay? And here are the the files are there for you to download. And here we are. We're talking about computing the minimum cost given and we change the supply value. So we change the supply, okay, at these locations. And then we wanted to say, okay, what does the minimum cost look like with those changes in supply? All right. And so it's just simply a matter of just, we use the solver to do that. And we'll click over here on data, and we'll come over to the solver. All right. And here we can see it's a minimization problem. We assume these are simplex LP data. And then the changing variable cells is B17 to E19. And you can see those. All right. And then we have the constraints, all right, and that's going to be B20, E20, and then also we have a constraint of F17 19. And the top set of constraints, these have to be equal. And then down here, the F17, those constraints have to be equal to or lesser than H17 to 19. So we see those totals, okay, and the per destination, changes in supply, and how it impacted it, okay? And so if you want to see in the book, it will give you the, in that Foster problem, again, page 257 it shows you that type of shows you all the elements of a transportation problem. The nodes, which are the destinations or the circles, the arcs, and those are the lines in between, okay? And that's pretty much what you were dealing with. And then they walk you through over to the solution, and they give you the solution for that, the original problem at the bottom of page 259. And as you can see, that was the optimal value was 39. But with some changes in supply, we got that down to 37,720. Now, out in the real world, big firms, well, the big dogs on the block, UPS, FedEx, and the United States Post Office have tremendous computing capacity that set these routes up on an hour. They set these routes up on a daily basis, and they can even adjust them by the hour or the minute that stuff comes in or needs to come in. And again, you hear a lot about driverless vehicles, okay? That really is going to start with huge, like semi-trailer trucks. The big problem in logistics and transportation is what they call the last mile problem, and that's where they really do need human beings. So you can see this new supply values, okay? And then we had some new supply values in terms of the sensitivity analysis. We look at allowable increases, allowable decreases, okay? And we start to cull through those to see. And we also look at the shadow price, which is also known as the dual values. The text talks about what type of change do I get in the objective function if I change one unit, okay? And then they've got a sensitivity report number 1, okay? And this is from the original solution. So that's what we ended up with. And again, these are going to be just like load balancing problems that we started out with. Or how many chemicals of this should I have? How many components of that? It's again, this is a load problem, and also really I guess the book talks about being a maximal flow problem. I'm just not sure. Anyway, all you have to do is upload that, and you've got the Foster done. So that one's due, and I'll let you explore it as much as you would want to, as much as you would care to. So I'm going to close that off and just shut that down. And we're done with that. And I'm not going to save any changes. Now, I want to go over here and we'll go back to, let's go back to the files and let's find Gorman. Okay, and there's the key, and we'll download it for just a second. I give you these, although I ask you to change some of the variables, because what you'll get into now, you know, if it's a really complex situation, like a trucking firm or a firm that's a logistics firm, a lot of this is going to be worked out as much as possible, and you'll try to build some models for it to work. But you know, the models break down when you have things like construction, or things like a bottleneck that occurs, or any one of those types of things. So you can try to build the model if you want, okay, and you should, but you probably ought to simulate it a few times at least to make sure you see what you're getting. And here we did some changes in the arc and the shipping. And again, the arc is the activity between nodes to get from one arc, from one node or destination to the next. And so I ask you there to compute the total distance, you know, given these changes, an 11.1% increase in the arc distance, okay? And then a 2.8% decrease in the arc 5 distance. And here we get the total distance. And again, pardon me, I wanted the solver, excuse me. And there we are. Now, the reason I don't try to bamboozle you with giving you a whole bunch of hard problems to solve or something is this. If you understand it, that's what's important. The most important, that's what's important. Perhaps what is the most important, even more important, is that you understand where did we get the data, okay? And the Foster model, for example, on page 257, all right, that's a flow diagram. And we even talked about doing it. I think we had a pharmacy or something that was filling a prescription, and it's a flow diagram that watches, the flow of stuff and how much it costs per unit to send stuff from one node to the other. And notice you have supplies, okay? Those are the inputs into the system. Then you have a throughput, that's the plant or the origin node, okay? And then that plant number 1, you could see the costs as it goes to Chicago, it goes to St. Louis, and it goes to Lexington, all right? And you can see then those are the distribution routes, and then of course the demands, system demands each of those, the customer demands at each of those locations, and trying to balance them. The question is, do I have the right cost? Do I have the right data? Do I know the demand? And have I worked with my suppliers to have the supplies? In other words, how valid are the data in this model? And that's where you come in. And that's something that just is a function of experience more than anything. The authors walk you through the math of Foster and all that business. Same thing with Gorman. Gorman's over on page 276 to 278 in your textbook. Let me pop down here for just a minute. I'll back over here to, and I think it's going to be this one. Assignment problem. No, I want 276. I'm still fighting my way through navigating with this book. So I want to go away. So hold your eyes. It'll make you dizzy. And it's 276, 278. And we'll get over there real quick. Okay. Yeah. Now this is, in addition to load balancing problems, then we have a different type of network problem, okay? And that's the shortest route problem, okay? So when we have something like with what we have in the Foster case, where we know the routes, the cost or the resource expenditure for the routes can be over time, can be worked out fairly simply, because you get enough experience with it to know the variability, and that in itself would be almost really a whole course, just getting those. How do you get those figures? How do you verify and make sure they're right, etc. Now here we have a little bit of a twist on that, because we're trying to find the shortest route. This is going to be in this case deals with time sensitivity. And that's why we're concerned about the shortest route, because we've got to get it there as fast as possible. And since you want to get there as fast as possible, you want to use the shortest route. Now, let me say this. These can also involve, okay, not just distances, but carrier or type of carrier. You may have to decide, okay, who gets the stuff there faster for me? UPS, FedEx, maybe even the Postal Service. If I have a bulk of stuff, should I have 10 FedEx cargo planes, bring the stuff in and dump it in the distribution center, or should I have them send it via water and send 100,000 units because I can get a tremendous price break? It just depends on that situation, okay? And it was really interesting. The years that I lived in St. Louis, one of the things And then I also lived in Cape Girardeau, Missouri, where I worked at the Missouri University down there, which is right in the Boot Heel and right on the Mississippi River. And what I enjoyed is my house, I could walk up the hill and I could see the river. And I enjoyed going up and seeing all the stuff going down the Mississippi, these enormous barges, sometimes a mile long. And they'd have cars, they'd have, look like wheat, who knew? But there was somebody who was getting a tremendous price break who assumed the best way to do that was to send it. And they were probably headed for the port of New Orleans to be loaded onto cargo ships and sent their merry way. But here in this situation, we're talking about time-sensitive stuff. So what's the shortest route problem, okay? And what is the shortest route to get there? Well, let's open up the Gorman key, download it. We'll take a look at it. And these are to be, you can upload them. And here I ask you to go ahead and compute the total distance again in terms of these changes in the arc distance and increase in the arc 1 distance and a decrease in the arc 5 distance. And this is something you're always balancing, especially if you're dealing with these kinds of problems can run the gamut from I'm shipping stuff from I'm shipping stuff from Southeast Asia or from China around the Horn of Africa, and the best way for me to avoid pirates and people on the high seas that would want to take my cargo is very simple. I go as far away from land as I can get, because those people are simply not going to have equipment that will let them survive out in the open sea like that. So that could put some delay on your time. Or if you're using the Suez Canal and some major military conflict breaks out, stuff gets backed up, or something happens at the Panama Canal. So you have to look at these. These could even be something as simple as they've changed the one-way routes in Oklahoma City, or they've changed the stoplight timing, or they're doing construction. And so these are things you have to kind of nurture and work along all the time. But I wanted to let you see that. And the problem over there, let me pop back over here because I think I'd gotten to the book. Yeah. As you can see, all right, this is also a type of problem that's ripe to what we call PERT CPM, Program Evaluation Review Technique / the CPM is the critical path method. My brain went dead. Let me show you what I'm talking about. Critical path method is the one that takes up the most time. Now, if I go from Gorman's office over here, and if I go node 1, node 2, and I got to get to 6, I'm talking about 39 miles. If I go the other route, I go 20, 6, and 7, I go 43 miles, okay? So if I've been using this southern route, if you want to call it that, I've got a slack. I have a slack there, and I really ought to bump it back down to the northern route because it just simply takes longer. If I decide to go route 1, node 1 to node 2, that's 25. Node 2 to node 3, that's 28. There's 34. There's 41. So I might choose to do this. Now, this, of course, is a rational model that assumes that I can either drop stuff at these customers as needed, or they'll accept that type of routing, or I can meet their time days. This node, this destination might want stuff on Tuesdays. These people might want stuff on Wednesdays. It just depends. So I show you these models and then try to give you enough to understand they're a starting point for us, not an ending point. And that's what they're designed to be. And that's why the textbook over in chapter 1 talked about the difference between problem solving and decision making, and walks us through that whole process of using a management science approach. And that is, we try to figure out what's the objective function, what do I want to get out of this, okay? what decision variables have I got to deal with, and then what constraints, and what type of data am I dealing with, and am I dealing with linear data? Am I dealing with data that configure themselves in a different manner? And we'll see some of those later on. I hope that doesn't mean I'm losing this, because it's going to not make me happy. I'm on the T line as it is, so I should be on there. So if we lose it, well, I'll just have to try to do something else. Now, before I go any further, it just kind of occurred to me, I want to make sure that we get ready for everything. So you've got the Gorman there. And I want to come down and talk about where we're going to head after we come back from break, because we're going to take a little bit of a different turn, okay? And of course, there's no classes, all right, on spring break. But when we come back for Module 8, okay, which starts that 3/26, 3/20, and then we don't have any classes on the 30th, that's Good Friday, we're going to start to use the book Data Smart, and that's the green one that says Data Smart. And I'll just go over here I'll go to Amazon. Let's see what it looks like. You should purchase it. And we're going to deal with what we call unstructured data. And we got a few cases in that we're going to play around with. This is the book. You should have it. If you haven't gotten it, you need to get it, because we'll be going through 2 or 3 of the models, and he uses Excel that he uses to deal with unstructured data, and also takes us through a technique known as naive Bayes, and to do some predictions. So we'll be using it, and he has I think a link over there to the book website, and I know I have the files over there, but I think you'll find this a nice kind of a refreshing break from what we've just kind of marched through these optimization problems. And this guy, he is, I think is it MailChimp? I think is the name of the company. They provide mail services to firms, and what they do is they try to find spam and get rid of it and all that type of thing. But he's got some other cases. One of them will do that. We're going to use cluster analysis. So I'm going to let you kind of see when you get out there and you hear people talking about data science or analytics or unstructured data, you'll get a little bit of a taste of what that looks like. So we'll be headed off in that direction. So I wanted to make sure that you knew that when we come back, we're going to start on that textbook. And this guy he's just scary smart, and does some really elegant things with Excel that other people just don't seem to be able to do with even more robust, or they think robust, tools. Now, we've taken a look at Gorman, okay, and that problem, and I want to go back over here to the text. All right. Again, this is the shortest route problem. And then they show us a transshipment problem, okay? And this is where it gets really complex. What you'll notice is now that you have arcs that run both directions. Arc 2 to 3, arc 2 to 4, arc 4 to 5, okay? And so you have inside this network a little bit of a hub going on. Each of these are kind of a hub. So origin 1, node 1 to 3 to 5 to 6, but you've also got some now your problem has become more of a problem. And notice we called it a transportation problem, okay, or shortest route problem, and now we're talking about a transshipment problem. And this is probably one of these situations where either node 2 or node 3 and node 5 have a finished component that's shipped on to the destination node, forward even. So you probably have these three nodes, 2, 4, and 5, are going to be something that where something is assembled either completely or ready to be sent on, and maybe destination node 6 is another assembler. Who knows? This is closer to what you'll see in terms of a supply chain out in the real world, especially with manufactured goods. And like people that do packaging, they'll work with all manner and sundry of company. They don't just package one product. And automobiles offer these same kinds of challenges, simply because all of these automakers, if they can get one universal type of piece of equipment in, they'll do it, because it just reduces their costs and makes it just, it makes them also makes it that much easier for them to talk about country of origin, because every cars are especially sensitive items, because people are always saying, okay, what percentage of this car was made in the United States, made in Germany, wherever? It's a political hot potato. So the manufacturers of those products, manufacturers of cars, really have to keep track of who did what, and you'll even see signs and stickers. So this is a transshipment problem, and then you can see this gets a little bit more complex. Okay, and they begin to walk us through a minimization function. And then we see those flow problems, flow out and flow in by each node. Okay, and they give us the constraint they got to be 0. We'll pop over here, and here's the whole linear programming problem on this shortest route in these transshipments. And you can see the origin nodes, the transshipment nodes, those constraints, the destination, and then they show you the solution. And you can see, okay, by each variable reduction, if the change in value I can get, okay, if I reduce that value a little bit. And again, you would work these, but it's not always going to be a rational process. You're going to try to get to the process as rationally as you can, but that's not always going to be the case. Now, I'm going to go back over here for just a moment to the course module, and we've talked about Foster and then about Gorman, and we've got some other cases coming up here: Martin Beck, Ice Cold, and RMC. And if I'm not mistaken, those are over in chapter 7. So I'm going to go back over here. I could be wrong. Let me see. Ice Cold's 323 to 324, so I'm pretty sure they're chapter 7. So let me go back over here. And we'll go down to chapter 7. And yeah. Okay. Now, that's the Eastbourne Realty. I don't want that one. Gorman, which is going to be oh no, I want 323, 324. We're close. My apologies. All right. Okay. Here we're going to try to establish some boundaries, or bounds, if we will, using the LP formulation. Now, pop back on over here, okay? And I want to see 323, 324. Hang on a minute. Did I fool my own self? Put in the wrong pages. I wanted Ice Cold's what I want, so let me pop on over here. I had some notes on where it's at. Well, I'll let you find that on your own, the textbook. But let's go ahead and just go ahead and take a look at the files. I've got the Ice Cold explained, and we can just download that file and talk about it, okay? And we'll take a look at it, because I've got a pretty extensive set of instructions for you there that we want to do, okay? And let me get this up. Okay. Now, I ask you to enter some values into this cell E20. Now let's find E20. Okay, we'll find E20, and what we're looking at is the net present value of what we're working with here is a capital budgeting exercise. Okay, and since I'm seeming not to find it in the, let me take the textbook here for just a second. $324, $325, $326, $327. That's strange. Well, I'm just scored from my hard copy, but basically they're talking about the capital available, okay, per period. This is the NPV we're going to get, and we're going to use, and we use the simplex LP to try to determine how much we should what projects we should do, and how much we should allocate each year. And so this is a situation where we're dealing with a capital budgeting exercise, and this is one where we've got to make we have to make a choice on what we will or will not do. So we're not going to be able to fund everything that we want to fund. And then we see the constraints here. Okay. And we try to get the maximum net present value. Okay, and here are the investment plans, and that's what we're that's what we're trying to work toward. Now, on the data, let's see if I can get that one to open up, or it's going to go nutty. Oh, it is already. Or I'm sorry, pardon me. We'll go to solver. And here we see we're going to set the objective, okay, and that's of course down here in D16, and we want to maximize it. And there are the changing cells, C20, okay, through F20, and there they are. And that's what we're invest in: a plant expansion, a warehouse expansion, new machinery, or new product research. And then we have the constraints. We had done a capital budget or a portfolio, excuse me, before, and really the idea is not any different at all. If we have the money and we think these are mutually exclusive projects, we'll fund them all. Google does that. If we're not, and we live in the real world, and they're interdependent, then we have to make some decisions about what we can or cannot use our budget for. And so this case, which is again is over there, it starts on page 323 and goes to 324, 325. I walk you through the solution 26, 27. Boom. And they show you the solution for that there on page 325 using the lingo. Now, here's the solution as I ask you to put the data in, okay? And I say, put it in cell EF20, put a 1 and see the new result, okay? And you can try these out if you want to see how this will all configure itself out. And I give you some more instructions there, and you'll want to take it and play with it a little bit and see what it looks like, okay? And then as you work through it, we choose the NPV and the new product research because in the end they have the best NPV. Pardon me, they have the lowest NPVs, and so this is just simply a case of using the solver to do some more, to handle this like a portfolio. That's all that's going on there. The logic of it's pretty simple. Here's what I'll get for my money. Here's the investment I have to make. Here's the capital available. And these are my constraints. And this is, and I choose whatever investment plan I choose, investment plan 1. That way I go, okay? And you can try these and you can put in a 1 or 0. Now, You see, what's the 1 and 0 about? Well, this is a binary choice situation. So 1 means it's a go, 0 means it's a no-go. That's what the 1 and the 0 are all about. Okay, so we're either invoke it or not. So I would assume they're assuming here with the binary that these are going to be mutually exclusive. Okay, see, and again, I hope I've impressed on you 2 things. One, the versatility of this tool, but more importantly, the methodology that's involved. And that is, what am I trying to accomplish? Okay, what things do I need to change to get to that goal? Okay, what constraints do I have? And what did the data look like? And distribution. And if I'm looking at what I think would reasonably be linear data, then that's fine. If I think I'm dealing with data that look more like a facade, like you might see with a restaurant or retail outlet, then that's a whole different kettle of fish. Okay. But the other thing is, okay, where did I get these figures in terms of what I think I'll get? All right. And then the expansions. Now, the one thing about this that I do like, if you look up here in the investments per year, okay, the capital investments, they don't assume an annuity model. Most of the time, you're going to see people in textbooks, if you have capital budgeting course, they'll start you off with annuities. The company's going to get $1 million a year for the next 10 years. The hurdle rate's 6%. What's it worth in today's money? Okay, that's a sleeper. Now, there's a function called XNPV, which allows you to use uneven cash flows, and that's more like what you typically see. Really, what you usually will see in a project is losses for about 2 or 3 years, and then you'll hit 4 or 5 years where you're going on, and then and if you haven't had your if you're a finance major, you understand what I'm talking about, and you've had financial management, you'll hit what we call a horizon value, and that is some value we assume in terms of net cash flow that we're going to get forever, which is a big assumption, but that's how we kind of tail off those problems and try to deal with them. Of course, the further you get out with this, all right, the less likely that becomes. So once I have a fairly high confidence level in these numbers, okay, I could, if I wish, I can play around here with go, no go, and see what that all looks like. I probably, just to be on the safe side, would go ahead and I would probably try to, randomize those those capital values for each of those projects. I'd probably randomize them and see what it looks like. Okay, and now if you assume, and I think this does assume these are linear, okay, and here's why this is important. If I can assume these data are linear, what this means is I can use things like the mean, the standard deviation, the variance to provide a probabilistic picture of what I'm likely to get. Now remember, when we talk about the so-called bell curve and linear data fit into it, we're talking about 34% of everything is between the mean and sigma 1. 34% is between the mean and sigma -1, and then 14 for sigma 2 on each end, and that's 34, and 14 is 48, and then the final 2% is on sigma 3. And so you can figure that if the data are distributed normally, roughly 68% or 2/3 are going to fall within a band, a zone. And that's what you could reasonably expect to get. Okay. Now, you'll see problems, and you probably see them in some of your finance textbooks, which just makes me cringe, is when somebody just from the seat of their pants says, well, if we put our money in common stocks, it's an 8% return, and we're 90% confident that's what we'll get. Good luck. That's a recipe for problems. And then when you get into derivatives, it gets even worse. I remember the first derivatives course I took, my professor said, this is a simple proposition, limited gain, unlimited liabilities. And he charged it for us, and he was right. And we found out how that works when you tie derivatives to capital goods like homes. Things get bad and go south fast. So this is a binary choice in this ICE code. They're trying to work around this, and you might play with an experiment and again take a look at the text, and they're just giving us another one of these applications when we have a go, no go kind of situation. And that's all that's going on there with them. Let me see here. I'm going to close this off for just a sec. All right. And I'll go back over here to the modules. And I think if you're smart and you want to have a nice break, you probably will front load a lot of your work. I would if I were you. Okay. Now, I think what I'm probably going to do is hold off on Martin Beck and RMC. RMC is going to be the one that will take up some time because we're going to look at it with and without setup costs. And RMC is over on pages 324 to 327. Martin Beck's over on 327, 331. So what I did is you probably have figured out at this point, I take each appendix in the problem and work through them. But just to kind of get you mentally prepared for RMC, okay, you're going to be looking at that. You're going to be looking at that problem dealing with if we have to have setup costs or we don't in a production environment, okay? And that's going to run the gamut from Walgreens to McDonald's to General Motors. You have an inherent problem. That is setup problem, and that's creating the line, okay, or the workflow necessary to produce what you want to produce. Now, if you're McDonald's, you know, if you go to any McDonald's and you walk in, you're gonna, if you walk through, if they let you walk through their kitchen, which you probably won't, but if you went through their kitchen, you'd see they have so many bins for fries. They have so many bins to put sandwiches in because they've worked the numbers out, and they know when you walk in one of those places, it's a factory, okay? And so you have to say, okay, if for example, that McDonald's decides to add a new toy in the mix of some movie or something, then they got to figure out how they're going to deal with that. Or if Carl's Jr. Decides to add a new sandwich or see how people respond to a new sandwich, that becomes an issue of setup costs. So we try to find a way to understand how to deal with those and to calculate them if we're going to introduce a new product line in what we offer in terms of a service product bundle, and setup costs can become extremely, extremely onerous. I mentioned earlier that automotive companies really, they all put their heads together to try to find out what universal kinds of things can we have in all of our cars. And there's one important reason. It's this thing called setup costs. When you decide to manufacture something, you have to figure out how you're going to do it and how fast you can do it. And you have to figure out workstations and workflows and all that. It just doesn't happen by magic. So you have to figure out, okay, if I take the line down, let's say I'm an assembler out here. Maybe I serve people in the energy business. okay? And they call me and they say, I need X number of units of whatever. And you then, okay, and right now I'm working on something else for another client, okay? I've got to figure out, okay, when can I promise this customer's just called when they can have the stuff, okay? And how long is it going to take me once I finish the batch I'm working on over here to boom, get it going? Now, I saw the magic and the mystery of this a long time ago when I was but a wee lad of about 9 or 10 when I worked in the back of my dad's restaurants, bussing tables and washing dishes. A very glamorous job for the boss's son. But at one of his largest restaurant, he had a guy who was a fry cook. His name was JD, and he could make anything taste. It was just a hamburger from him, steak from him melted in your mouth. The amazing thing was the guy just had this capacity, and a good fry cook will do this, to juggle about 25 things at once. And so he'd be cooking in the middle of a rush time, you know, and it was just, and I'd have to stop and just watch him because he was just like this machine. He could just, and he'd, you know, hit the bell and the waitresses would come up, and they had waitresses in those days, and call them servers, really call them servers, so I'll be politically correct. And boom, and they'd be saying, hey, slow down. But he was really good at that. And I saw that, and that helped me understand this idea about setup costs, okay? And it's the same thing that anybody that manufactures something. So we've got some models there for you with and without setup costs and what that entails. Then the Martin Beck. I never know, you know, and I'm probably going to finish off on this because we started about 10 or 11 minutes early anyway. I never really know what courses you've had, if you've had finance or not, or if you're a finance major and you've had financial management, which is, I think, is the keystone, is the capstone course for that major. Nonetheless, I always think it's a good idea for you to go back and look at capital budgeting basics. I've got some resources here on orders and setup costs. This is an old tried and true method, the Northwest Corner, and then some of these jobs and logistics. But the capital budgeting basics are the ones that are really, really, really helpful. And again, when I have people ask me about the value of these tools like Excel, I can just tell you a story. Early on in my career, I worked for a company that worked mergers and acquisitions. I was one of a team of cash flow analysts. And before, we had a not so very robust spreadsheet application. And at best, over 3 or 4, maybe 5 months of time, we could give a cash flow, we could generate about 5, maybe 6 scenarios in cash flow. Now, on a merger and acquisition, cash flow is everything, okay? Usually on a merger or acquisition, somebody's getting paid off, okay? It's usually the firm being acquired. Rarely does the firm being acquired pay the other firm to take them. Usually the firm sees some value and pays a premium makes an offer, and yeah. Now, you know, when you deal with regulated firms, pardon me, if you deal with publicly traded firms, it's out there for everybody to see, okay? In the past 20 years, we've had more merger and acquisition activity than we've had the entire history of business, or recorded business for that matter. But cash flow is everything. Usually there are two things that happen. One, somebody gets a payday. You know, I'm Instagram and Google buys me, and I'm going to get a payday because I have 1,000 shares, and each one of my shares are now worth at least $1,000, $1,500 each. I'm getting a payday. Well, if I'm Google, I better make sure I'm going to have the cash flow to sustain that premium that I'm going to pay. Okay, you've always got that one. You've always got that one sitting there staring you in the face. If you're a little more gutsy, a little more, I'll use a guy from the news. 2 people from the news: Mitt Romney, who works with a hedge fund, and Scaramucci, who's Trump's friend, who's also a New York hedge fund guy. When they say the words hedge fund, what they mean is they see something, a company of value, and they say, okay, we'd like to buy you. And instead of taking cash flow that's generated from the additional business, they borrow the money. And then they say, okay, they do a leveraged buyout. When you do a leveraged buyout, you better know or have a reasonably good assurance you can pay the money back. Because if you don't, it's bad news for everybody. And so, understanding capital investment is really important, particularly if you go to work for a large firm, because there's just so much of it going on, people being bought out. Where you're going to experience is that when you buy your first house, I would say that about 50 to 60% of you, when you buy your first house, one day you'll sign that you've closed on the house, blah, blah, blah. And one day you get this letter that says, we are now servicing your mortgage. Well, why is that? Well, people, whoever serviced your mortgage in the first place has moved on. They've collected their fees from you in terms of closing costs, and they've gotten a little bit of interest from you. And now they pass you on to a larger lender who wants your interest money. Okay. And so you can be traded among lenders based on your risk profile, the type of property you're in. It's a lot of different factors, but you'll find out. So it's kind of good to understand, why would I be with Bank One and then suddenly they sell my note to somebody else? Well, because somebody else said, I like their property, I like their credit history, I like what I see, they're going to be good customers. Boom. And I'm also banking that they will be able to sell their house at a higher price. So they're kind of speculating. Sometimes they hedge, particularly with very established areas. In Oklahoma City, you're talking about Heritage Hills. You're talking about Nichols Hills. There's one that starts with P. I forget. San Paseo. I forget what's the name of the place there. But houses there that they're averaging out about $1 million a pop. People aren't going anywhere. They're going to buy the house, and so a lender might come in and say, "Hey," to another lender, "Let me have that. I'd like to have that home because I think maybe I'm going to make some money off that house. Maybe they'll refi it and I'll get some additional income. Maybe they'll do a reverse mortgage. Who knows?" Well, that's pretty much it, folks. And you can see what we got ahead of you. I will go through this again some on Wednesday. And let me encourage you to do your work so you can enjoy your time off and do so and be safe. And if I don't remind you on Wednesday, I will remind you today. If you get tired, if you're driving home, stop somewhere safe. Don't stop at a rest stop and then wake up and somebody in a ski mask is there and all that stuff, like in the movies. Okay, thank you, folks. Have a good one. God bless you. Appreciate those of you who are here.